Let's explore the if-else statements in Go and how you can use them to make decisions in your code. An if statement in Go is simple. Here's how you check if a condition is true. If the condition age greater than or equal to 18 is true, the code inside the block will run. You can extend this with an else block to handle both true and false conditions. To check multiple conditions, use else if. This allows you to handle various scenarios in one block of code. In Go, you can declare and use a variable directly in an if statement. This variable will only be accessible within the if-else block. The variable score is declared within the if block and used throughout the conditions. That's the basics of if-else in Go. Try it out and see how you can use conditional logic to control the flow of your program. Let's dive into switch statements in Go and see how they can simplify your conditional logic. A switch statement allows you to execute different code based on the value of a variable. This checks the value of day and prints the corresponding day of the week. You can also group multiple cases that share the same result. This makes it easy to manage related cases together. By default, switch statements in Go do not fall through to the next case. However, you can use the fall through keyword to enable this behavior. This will print both it's Monday and it's also a weekday when day is 1. You can use conditions in your switch cases for more complex logic. This checks the score and assigns the appropriate grade. Switch statements can make your code cleaner and more organized. Try using them in your Go projects. Let's explore for loops in Go and see how they can help you handle repetitive tasks. A basic for loop in Go has a straightforward syntax. This loop will print the numbers 0 to 4. You can also use the range keyword to iterate over arrays and slices more easily. This prints the index and value of each fruit in the slice. For more complex tasks, you can nest for loops. This will print the multiplication results for numbers 1 through 3. You can create an infinite loop using for without any condition. Use this cautiously. Always ensure you have a way to exit infinite loops. That's a quick look at for loops in Go. Experiment with them in your code to master repetitive tasks. Let's explore functions in Go and see how they help structure and reuse your code. A function is defined using the func keyword. To call this function, just use its name followed by parentheses. Functions can accept parameters and return values. Calling add 2 and 3 returns 5. Go functions can return multiple values, which is quite handy. Calling a b equals swap 1 and 2 gives a as 2 and b as 1. To make your code clearer, you can use named return values. This allows you to return values without explicitly using the return keyword for named returns. Functions are key to writing clean and reusable code in Go. Practice creating your own functions. Let's explore how to use multiple return values in Go and why they're beneficial for your code. In Go, you can define functions that return more than one value. This function returns 2 integers representing coordinates. A common use case is returning a result and an error. This function returns the result of the division and an error, if applicable. When calling a function that returns multiple values, you can unpack them easily. This shows how to handle both the result and potential error. You can also define functions with named return values, making it easier to return multiple values without explicitly naming them each time. This function returns the result without specifying it in the return statement. Using multiple return values can make your code cleaner and more efficient. Try implementing them in your functions. Let's dive into variadic functions in Go and see how they allow for flexibility in handling multiple arguments. Variadic functions can take a variable number of arguments. This is useful for functions that need to handle different amounts of data. To define a variadic function, use the ellipsis syntax before the type and the function parameters. This function accepts any number of string arguments. Here's a practical example where we sum a variable number of integers. Calling sum 1, 2, 3 returns 6. You can also use variadic functions with different types, including mixed types, by defining the parameter as an interface. This function can accept any type of argument, making it highly flexible. Variadic functions can greatly simplify your code. Try implementing them in your own projects for more flexibility. Let's explore pointers in Go and understand their importance in memory management. A pointer is a variable that stores the memory address of another variable. This allows you to directly manipulate the value at that address. To declare a pointer, use the asterisk operator. Here's how to initialize a pointer. Here, p is a pointer to x, and $x gets the address of x. You can access the value stored in a pointer using the asterisk operator to dereference it. This prints the value of x by dereferencing the pointer. Passing pointers to functions allows you to modify the original variable. This function increments the value of x directly. Pointers are essential for efficient memory management in Go. Experiment with them in your code for better control.